Hey everybody, Mr. Gajewski here, and today we're going to talk about solving compound inequalities. So what we've been dealing with previously are simple inequalities. A compound inequality is just two simple inequalities put together to form one compound inequality. So on the left-hand side, in that left-hand column, we have algebraic representations of some compound inequalities. The first two at the top are AND statement inequalities. The bottom two in the third and fourth row are OR statement inequalities. So how would we describe these? Well, in words, I'm looking at the first one here. So all real numbers greater than 2 and key word there, less than 6. And if we look at the graph there on the right, we have an overlapping section. So greater than 2 and less than 6. All of my solutions have to fit within that area. Same thing goes for the second row for greater than or equal to and less than or equal to 6. Let's talk about the OR statements. So a little bit different here. So I'm looking at the third column, or the third row, excuse me. So how do we say that? That's all the solutions are all real numbers less than 2 or greater than 6. Now, the graph here is a little bit different, all right? So it doesn't have to work for both simple inequalities. My solution does not have to work for both. It can work for one or the other, hence the name, OR. Same thing goes with that fourth column. It can be equal to in that case. So let's go ahead and let's take a look at some examples here. So we have a compound inequality. 4 is less than or equal to x plus 2, less than or equal to 8. Now this is going to be an AND statement. And the giveaway here is that an OR statement will always say OR. So if it doesn't say OR, you know you're working with an AND statement. So how do we solve an AND compound inequality? Well, we need to break this compound inequality into two separate simple inequalities. So that'll give me 4 is less than or equal to x plus 2 and x plus 2 is less than or equal to 8. We go ahead and we need to solve both, so let's go ahead and subtract 2 here. It's going to be 2 is less than or equal to x. I'm going to flip that around so it's going to be easier for me to graph. X is greater than or equal to 2. And on the right-hand side, we're going to do the same thing. We're going to go ahead and we're going to solve. We get x is less than or equal to 6. Now I need to go ahead and graph both of these. So I'm going to look for the smaller of the two numbers. So I have a 2 and a 6. Well, 2 is going to be on the left. 6 will be over on the right. And when I make my graph here, I'm going to start at 2. So that is greater than or equal to. So equal to, so it's going to be a closed dot. We're going to go ahead and fill that in. And it's going to be shaded to the right because it's greater than. If I look at my second one here, x is less than or equal to 6. So equal to, closed dot, shaded in, less than, to the left. So just like my previous chart, I have an overlapping region. All of my solutions have to fit within that area. Let's go ahead and let's take a look at another example of an AND statement. So again, let's go ahead and let's break this down into two separate compound inequalities, or two separate simple inequalities. Negative 5 is less than or equal to 2x plus 3. 2x plus 3 is less than 9. And then we're going to go ahead and we are going to solve each of these separately. So I'm going to subtract 3 and divide by 2. And again, it's probably going to help us graph if we go ahead and flip this simple inequality so that we have the variable on the left-hand side. Solve the second. And again, when I make my graph, let's go ahead and let's look for the smaller of the two. Well, -4 is smaller than 3, so let's go ahead and draw those on our number line. And let's start with -4. So greater than or equal to, that is a closed dot because it's equal to, greater than, to the right. Let's look at our second inequality. Less than 3, so less than, open, shaded to the left. So those are two examples of and compound inequalities. Let's look at some or compound inequalities. So again, the or compound inequalities, the dead giveaway, they will say or. All you need to do is go ahead and solve. So we're going to solve both separately. Go ahead and add, not sure why I wrote a 5 there, let's add 4. A is greater than 5. Add 4 here. A is less than 1. So again, look for the smaller of the two numbers. So I got a 1, so I'm going to draw 1 here first on the left. And I have a 5, so I'm going to draw my 5 on the right of the number line. Let's go ahead and let's graph each of these. So A is greater than 5, so open, greater, shaded to the right. A is less than 1, so that is again going to be open, shaded to the left. So again, with an or statement, my solutions can be in this region or this region on the right. They do not have to work for both. They only have to work for one of these inequalities. Let's do one more example. So again, this is an or statement. How do I know? It says or. Go ahead and solve both separately. X is less than or equal to 3. X is greater than 4. 3 and 4. Plot the smaller one on the left. Plot the greater one on the right. Less than or equal to 3. Equal to meaning closed dot. Less than shaded to the left. Greater than 4. Greater than, that is an open circle. Greater shaded to the right. That's it for solving and graphing. Well, how about writing compound inequalities? So I'm going to go ahead and I'm going to look at this graph and I'm going to try and write a compound inequality. So what I'm going to do here is I'm going to think to myself, is this an and statement or an or statement? So an and statement, if you remember, is going to have an overlapping region. An or statement is going to have two diverging lines, so two lines that are going away from each other. In this case, we have two lines going away from each other. So I know this is going to be an or statement. So I'm going to write two separate compound inequalities. So I'm going to look at the inequality on the left. So this simple inequality, well, I'm going to pick a variable. Let's do x. And it's going to be, well, to the left, less than, closed dot, equal to, what value? -1. Let's do the same on the right. Start with your variable. Shaded to the right, greater than, closed circle, equal to, what value? 7. Now that's it for or statements, we can go ahead and circle our answer. Let's take a look at one more graph. So again, now this time we have an overlapping region. So we know it's going to be an AND statement. It has to work for both inequalities. So let's go ahead and let's start on the left. So when I start on the left, well, I need to pick a variable. Let's pick x. It's shaded to the right, so greater than. Closed dot, equal to. What value? 0. Then we'll write and. Well, what variable am I going to use? I'm using x. Shaded to the left, less than. Open circle, so I can leave it as is. What value? 6. Now I could leave my answer as this, but sometimes your teacher might want you to write one long compound inequality. So how would we do that? Well, what we're going to do here is we're going to start with the smaller of the numbers, 0. And we're going to write this symbol that goes with the 0. We're going to write it as a less than or equal to my variable, x. And then we're just going to rewrite the second inequality. Now we've already written x, so we don't have to write it twice. But we'll go ahead and we'll take this portion here, the less than 6, and write less than 6. So either of these two would be correct in writing an AND statement for this graph. All right. I know there's a lot to that, solving compound inequalities. Just take your time. Remember the big giveaway of what you're working with. An OR statement or an OR compound inequality will always have OR in it. If you don't see OR, you're working with AND. That's it. I hope that helps. If you have questions, let me know. I'll see you next time.